I'm Chris Dale of the UK-based e-Disclosure Information Project. I've been speaking and writing about e-discovery and its related topics for many years. E-discovery embraces other and related topics from archiving through to privacy and cybersecurity. Central to all these subjects is the problem of identifying data, knowing what you have and where it is. SullivanStrickler's business is providing access to the vast amounts of legacy data kept by organizations. Much of that data is on systems whose hardware and software has long fallen out of use. Much of it is on tape. A lot of it is kept because it contains data which may be needed, perhaps because for future possible litigation or for regulatory reasons. Much of it still exists just because no one knows that it's there, or because lawyers have said that it must be kept for some unspecified purpose. Much of it still exists because no one has time to look at it, quite apart from the practical difficulties caused by old formats or redundant systems. This kind of data has always caused problems for e-discovery and for regulatory purposes. How can you say you've found everything relevant when you don't know what you have? There are newer issues as well which make it increasingly important to know what data you've got. One is cyber risk. How can you say what you've lost if you don't know what you had? How do you assess the risk? And if you can't assess the risk, how do you know what resources to apply to that risk? The other area lies in privacy and data protection. There are new laws which increasingly encourage individuals to ask what data you hold on them. The EU's General Data Protection Regulation, for example, applies to many US organizations, and the US is seeing an increase in privacy regulation, such as the California Consumer Privacy Act. SullivanStrickler was founded to deal with exactly these problems. I'm talking here to Brendan Sullivan, CEO of SullivanStrickler, and Fred Moore of Horison. Brendan, tell us briefly who you are.
I'm Brendan Sullivan. I'm the CEO and co-founder of SullivanStrickler. We formed this company in 2013. Me personally, I've been involved in tape since 1985, working in Europe on the development of the first square tape cartridge, 3480. Working in production, manufacturing, engineering, sales, marketing. I moved to the States in '99, and for the last 20 years I've been involved in the services and software of restoration and discovery of data from tape in support of legal, regulatory and business practices.
Fred, how about you?
My name is Fred Moore, and my career started with Storage Technology Corporation, a large data storage company, a major focus on tape technology. I spent 21 years with that company and finished as the corporate vice president of strategic planning and marketing. 20 years ago, I founded Horison Information Strategies in Boulder, Colorado to continue to get deeper into the storage industry. And today I write the annual report for the Tape Storage Council, the Active Archive Alliance, and do a lot of publishing and consulting with tape companies.
Brendan, the discovery industry, indeed me, because I've known you for a long time, has known you for tape restorations for the past 20 years. What's the business model for SullivanStrickler? What's different about what you're doing now?
So, our core competencies have probably not changed. We're essentially an engineering company, a lot of IT engineers, software engineers, and we understand data right down to the hex level. And how this has lent itself over the last 20 years has enabled us to write routines and code that emulate what backup softwares do, so that we can get access to that data and so that we can produce that data potentially right through to the courts in a defensible way. That technology development has lent itself to all sorts of other potential uses. And as you mentioned earlier, with the increase in focus on development of regulations, privacy regulations such as GDPR and the CCPA, but also modification of some of the federal rules in and around how data is to be produced and how it's to be managed. There's a surge in companies' requirements to tackle their large data mountains at an information governance level, the way they manage their records, the way they retain them, the way they dispose of them, remediate them, produce them, keep them, and so I would say that the technology that we've learned over the last 20 years as individual engineers and practitioners within this industry is now leaning itself more towards solving problems at a corporation level within information governance type environments.
So what do you see as wrong with the off-site storage vaulting model as it stands now?
So, not sure I'd say what is wrong with it. I think there are gaps. I think there are the reasons that it's evolved. The off-site storage model, as it pertains to backup tapes, became very prevalent and through its growth years as being a short-term physical location for the movement and transport of daily or weekly backups, rotational media as it might commonly be termed. And so consequently, when you have that kind of requirement to produce data, create data, move it off-site for secure reasons, and then bring it back on and write it over, that data is a backup, and it already exists within the corporation. So as a result of it already existing, intelligence about the data that's on that tape is not really required once it's in an off-site storage facility. This is where data should go to stay for a long time. This is where it should ultimately die. But the problem is that the way the industry has been brought up over the last 20 years is there's no intelligence. There's no business analytics, there's no data analytics that come from that unstructured data, which, as statisticians, I think Fred mentioned to me yesterday that 80% of data that's out there is unstructured. If there's no business analytics, then you can't make informed decisions about it. And so consequently, we feel that there's room for a new type of off-site storage vault, a company that, or a capability that can provide analytics, remediation, deletion, production, without the risks of moving data, without the risks of physically moving tape, without the delays and the time it takes to move those tapes back to a location where data can be read, and without the costs involved of storing what essentially is 80 to 90% of companies' data that is largely either not wanted, useless, or frankly a liability.
The analytics we're talking about here, is that much the same as we know of in e-discovery? Has it developed at the same pace, offering the same sort of approach?
So I think we're dealing with huge amounts of data, petabytes, zettabytes of data that is in an unstructured manner on backup and archive tapes. And analytics on that data it's expensive and cumbersome. It's much the same as analytics on any kind of data, in that you can only provide true analytics once you've indexed and processed at a text and metadata level the data in those storage mediums. This is not practical. If you have 100 petabytes of data and you want to provide analytics on 100 petabytes of data, it's a hugely expensive and time-consuming exercise. The analytics that we provide is at a metadata level and a backup session level. There's some great information that is relatively easily obtained from backup tapes or from backup databases that is metadata and backup session. Backup session, I mean, when you're creating a backup, you might have an Exchange backup, a print server backup, document management servers. That can be critical information that would allow you to either leave it behind or keep it, produce it or ignore it. And it's relatively quick and easy to get that type of information without delving into the raw content data itself. And the same with file level metadata. We can extract file level metadata from backup tape and then provide analytics on that metadata so that decision making can be made regarding the data itself. So it's similar in that there's a review and search, not similar in that we're not indexing content, we're indexing metadata and backup session level information.
Turning to you, Fred, can tape really be an alternative to the cloud as an archive medium?
You know, that's one of the most common questions I get today. regarding tape in the cloud. And I think it's important to realize that the major cloud providers in the world have gone heavily into tape as an archive solution. So they've endorsed tape in the same game that the traditional data center tape is. And to me, the question is, what can they do with the tape in these cloud data centers compared to, say, what SullivanStrickler can do? And with Brendan's business, he can actually go into the archive and add intelligence to the archive. I call it reawakening the archive, because with metadata and various other capabilities, he can make the archive searchable and play right into the e-discovery big data world that awaits it. So tape is actually a very good archive solution. It's got the best total cost of ownership of any storage technology. It's green, and it favors data that's not used a lot. And archive data is often called worse data, write once, read seldom, if ever. So this data really plays well to tape, and if it's tape in the data center or tape in the cloud, my question is, who can do what with that tape? And that's kind of where the SullivanStrickler comes into this picture.
Brendan, you'd presumably endorse that.
Yeah, I think, as I mentioned earlier, our technology, it's been learned over the last 20 years. Those technologies that you've learned over a period of time of working in the discovery model make them particularly useful for selective distribution or selective remediation, deletion or migration from a lot of these large unstructured data pools. What we've done is we've created the ability to migrate data. So there's a need to remediate, there's a need to delete, there's a need to ignore, and there's a need to keep. And unfortunately, over the last 20 years, as backup systems have evolved, the way that data has been pushed back to tape or pushed back to any storage medium for that matter has not always been in the most structured way. It's not always been in the most intelligent way. And of course, now when it comes to restoring or unraveling, you want this, but you don't want that. And therein lies the problem. So companies have never really tackled the purging of data they don't want and the retention of data they do want. It's like looking under a stone. Once you look under, you see something you don't like, you put the stone back. What we've developed is, rather than a selective means of deletion, which is very difficult because you can't append data that's been written to tape, our approach is migrated and selective migration. So what we've done is we've created a combination of skill sets. The first is the ability to create an image of a physical volume being a tape. We'll call it a logical volume. So that logical volume from a small capacity tape can go to a large capacity tape. We can shrink 100,000 tapes, put it all on 5,000 tapes, refresh it, make it suitable for archiving for the next 50 years. That's stage one, but that's the easy bit, so to speak. We call that a tape session file or a tape duplicated file. It's a physical volume that's been logicalized, and then we'll use LTFS, linear tape file system, to be able to restore those individual historical source volumes when we need. But the clever stuff is to understand the data that was backed up in the source environment at a backup session level. As I mentioned earlier, backup sessions, they could be exchange sessions, print server sessions, document management, file share, whatever. Classifications of data that have been backed up from specific servers. Sometimes those retentions are long, sometimes they're short, sometimes they create liability, sometimes they don't. They're typically separated by file marks within those backup session environments, and they might be multi-threaded across tens or even hundreds of backup tape sets. What we do is we migrate from the old source media to a new media. We don't land data, but we selectively pick sessions and reconstitute those sessions on the destination logical image. So the beauty of this system is that is that we never land data we don't have to restore. Restoration of data is expensive. If you're going to take 100,000 tapes and restore the data, it's expensive. So projects, they never get tackled. But if you're going to migrate it and pick what you need as it's passing through our migration technology, then you get around those costs. And as well as getting around those costs, you're consolidating the future storage costs. And you're also decreasing the requirement for the data center to retain legacy backup software, legacy backup tape libraries and equipment, and keep around other resources that are required to restore that data. It's on the latest technology. And a further development of that is when we're making that migration, we also extract file-level metadata. Things like file extension, file name, path, create, modified, and access date. And we'll port that to a web portal software we have called Inveneer. It's a review-style web portal that manages file-level metadata. And so in one multi-stage process, we're migrating, we're refreshing, we're compressing, shrinking, we're remediating or defensively deleting, and we're porting and creating data-level intelligence to that unstructured archive at the same time. And the outcome, as I mentioned earlier, it's a faster time to data. It's data that you want to keep. It's data that you have to keep. It's data that you're going to use in the future. And it's data that's refreshed, that on this current modern technology, modern tape technology, will last 50 plus years into the future.